Hello, my dear students, and welcome to this session of Unacademy NEET Elixir. My name is Anoop Vashishtha, and you are on this channel. This is an English medium channel, and today we are going to do a very important topic. Now, this topic is a very much neglected topic because people think that it's an easy topic, and that is why they make a mistake in the exam. So, are you there? Like, subscribe, share, and comment. Now, in this topic, we are going to do a lot of topics, lot of things, and let us consider a few stories, a little bit of stories. I actually wanted to ask you. Many a times, you are asked, "What is your height?" And some people say my height is 6 feet, my height is 5 feet 10 inches, and as I say, my height is 5 feet 11 inches. That is my height. Now, somebody asks you to give your height in kilometers, and you might be having just a thread or a rope which is 1 kilometer long, and then you have to measure your height with that particular rope. Frankly speaking, if you are trying to measure the height with a rope of a length 1 kilometer, then your height actually effectively is 0 kilometer. Now, quite obviously, that's an error. Why is there an error? The error is there because the rope does not have enough divisions, breakings to measure your height. So, here comes the error in measurement. So, any measurement that we have could be having some error in it, and that is because of the measuring instrument we have. There are certain unavoidable errors or inherent errors, but those are extremely small to be significant in the present scenario. So, let's talk about the measurements in chemistry, and with that, the errors in chemistry. So, as I told you about myself, my name is Anoop Vashishtha. I am an MSc in chemistry, 26 years of teaching experience, more than your age. In fact, 1.5 times of your age. Lakhs of students have been taught by me, and here I am. So let's begin over with the topic. Okay. First of all, we are going to talk about certain quantities. What exactly are the quantities that we are going to measure? Now, one of the quantity is the mass, the weight. First of all, you need to understand that in chemistry, same for chemistry. We actually do not distinguish between mass and weight as far as chemistry is concerned. So, from when physics lectures begin? They are going to begin maybe from Monday onwards. Alpita Panda, we are going to I'll give you the lecture or the PDF of the entire lectures, entire things. You are going to get all the lectures. Clear? आज का स्लाइड्स में व्हाइट बैकग्राउंड है. आज का स्लाइड्स में व्हाइट, नो इट इज नॉट व्हाइट, इट्स ब्लू बैकग्राउंड बेटा. White I am writing with, it's not white background. Okay. Fine. So that is what we term as the term called mass. Now once we have talked about mass of the substance is the amount of matter present in it. See, when we talk about matter and when we talk about mass, they are used interchangeably. When we define something what is matter, we define the substance as the matter as something which has mass and occupies volume. Whenever we say what is mass, we call about amount of matter. So matter and mass are defined interconvertibly. One is defined with the help of the other. And as far as this is concerned, mass actually is undefinable. You cannot define what would be the mass. You can define kilogram, but mass can't be defined. So it is again defined as the property by virtue of which the matter is defined as matter, or it's a fundamental property of matter, whatever you wish to, they are defined interconvertibly. So why? But when we talk about precisely, when we talk about physics, when we talk about weight is the gravitational force which is exerted on a body. So weight is actually a force which is exerted by Earth or any other planet for that matter on the object. So that force, the weight becomes the force with which the planet or the object attracts a particular body towards it. This was a joke that if you have a weight of 180 kgs on Earth, you are going to have a weight of only 30 kg on Moon. Weight, not mass. So, you are not actually fat, but you just happen to be on a wrong planet. That's what they have a joke. So, weight is going to vary. But if you are talking about 180 kg of mass, then in that case, this is going to remain 180 kg of mass even on Moon. Is that clear? So mass does not change with the place, but weight does change with the place. So weight is relative, mass is absolute. Is this clear? Not a problem, beta. We are going to start with states of matter chapter. The next chapter that we are going to start with will be states of matter, and I am going to talk about even other chapters. So here we have the mass of the substance, the amount of the substance. This is what we have as a unit of mass is kilogram. And SI unit of weight would be newtons, but most often we are using kilogram itself or kilogram weight. So these are the important things. Now that's what we have as the weight. Mass. Mass is the amount of matter that is termed as mass. Mass remains a constant irrespective of the conditions, the various units of mass. You need to have the interconversion of the units. 1 kilogram is equal to 1000 grams. That is 10 raised to the power 3 grams. Can you tell me 1 milligram is equal to how many kilograms? Can anybody give me the answer quickly? 1 kilogram, 1 milligram is equal to how many kilograms? Could you just give me in the in the chat box? And where are the others? Many people have not liked the session as yet. Wow, Priyanshu Ghosh has given me the answer. Piyush, think again. What have I asked? I have asked how many kilograms make 1 milligram. Piyush, think over it again. Other people also think over it. Okay, thousand, a million. Ananya Sarkar, 1 kilogram is equal to 10 raised to the power 6 milligram, and 1 milligram will be 10 raised to the power minus 6 kilogram. So you need to be very clear. These questions may be asked in your examination, and you might have a mistake, might commit a mistake by just a sign. So that is going to make a difficult thing. Is that clear? So the answer is going to be 10 raised to the power minus 6. So that would be the conversion factor. So we have kilograms, we have grams, we have milligrams. 1 gram is equal to 10 raised to the power 3 milligrams, and 1 kilogram is 10 raised to the power 3 grams. So 1 kilogram will turn out to be 10 raised to the power 6 milligrams. Is this clear? Now, once we have talked about the conversion unit of mass and weight, now here Could we tell us that here what are we exactly measuring? Are we measuring the mass or we are measuring the weight? What is being measured out here? Okay, think over it. Now let's get along with another unit, another quantity that we are going to use everywhere. That is what we have as volume. So when we talk about the volume, volume is the space occupied by the object. It is space occupied by matter. So that is what we call as volume. The volume is the amount of space occupied by a substance. It has a units of length cube. So we can have any unit of length. So SI unit, the volume has a unit of meter cube. So SI unit of volume is meter cube. The practical unit that we are using in chemistry is decimeter cube or liters. Still, when we talk about the work in laboratories, we are using the unit as milliliters or centimeter cube. So that is what the unit we use in case of chemistry, centimeter cube or milliliters. Is that clear? Hello beta, your Bharat, how are you? Prerna Rajput, it's weight, mass. Okay. So liter is a common unit, and here we talk about the conversion factors. The three-dimensional space occupied is termed as volume. The units of volume are meter cube, decimeter cube, liters, centimeter cube, milliliters. These are the units which we are using in our daily work. Now, you need to understand one very important thing, and that is 1 decimeter cube is exactly equal to 1 liter. 1 decimeter cube is exactly equal to 1 liter. So it can be used interchangeably, but most often we are using decimeter cube because it is easier to convert a decimeter cube into the units of length. But once we have the liter, we can actually have it equal to 1 decimeter cube, not a problem. Further, 1 centimeter cube is equal to 1 milliliter. Clear? Now, a simple question. 1 milliliter is equal to how many decimeter cube? Can you give me the answer? 1 milliliter is equal to how many decimeter cube? What would be the answer? Answer. 1 milliliter is equal to how many decimeter cubes? One. Namrata says 1. 1 milliliter is equal to 1 decimeter cube. What is the answer given by others? Okay, 0.001. Namrata again has given another answer. So which is the correct answer? First one or the second one? 1 milliliter, once you need to understand that when we talk about 10 raised to power 3 liters, it's equal to 10 raised to power 6 centimeter cube. So 1 decimeter cube is equal to 1 liter, which is equal to 10 raised to power 3 centimeter cubed, which is equal to 10 raised to power 3 milliliters. So 1 decimeter cube is equal to 10 raised to power 3 milliliters. So 1 milliliter would be equal to 10 raised to power minus 3 decimeter cube. So these conversion factors, although they are extremely simple, these are an extremely important part. These relations, when we talk about these relations, they are extremely important because here you are committing a lot of mistakes. Clear? Just don't do these mistakes. Okay. So that's what we have as the conversion factor. So you need to understand further, this unit is seldom used. We are not mainly using this unit anywhere, but in NCERT, they are using this particular unit at many places. So this particular unit, 1 meter cube, is a very, very large unit. This 1 meter cube is actually equal to 1000 decimeter cube or 1000 liters. So most often we are not using this particular unit, although it is an SI unit. Once we have talked about the thing called volume, here comes density. Density is mass per unit volume. Most often we talk about, if we talk about the SI unit of density, it should be kilogram per meter cube. But kilogram per meter cube is a too big unit. So most often we are talking about kilogram per decimeter cube, and better still, we are talking about gram per centimeter cube or grams per milliliter. So that is the most important unit that we are going to use. Although it is not an SI unit, still we are going to use the unit as grams per centimeter cube or grams per milliliter. This is the unit which is mostly used in chemistry, although it is not an SI unit. Density is an intrinsic quantity. By intrinsic quantity, I mean that whatever the amount of the substance be, its density is not going to change. If you take water, a drop of it, or you take a liter of it, or you take an ocean full of water, still the density would remain the same, although the mass and volume are going to change. Mass, volume which change with amount, they are called extrinsic quantity, while density is an intrinsic quantity. So density is an intrinsic quantity. Is this clear? So here comes the ratio between mass to the volume. The SI unit is kilogram per meter cube. This unit is very large and density is most often expressed in grams per centimeter cube. The conversion factors are the same. You convert the grams into kilograms into grams, and you convert meter cube into centimeter cube, and you get the answer. Is this clear? Yes, I am here with you. Clear? So that's what we have. Density of the substance tells us about how closely its particles are packed. If density is more, that means the emptiness is less and the particles are placed quite close to each other. Is this clear? Okay, here comes the temperature. Well, how many of you make a mistake in the spelling of temperature? Because I used to do it TEMPRATURE. I generally missed this E. How many of you make a mistake that missing that E of that temperature? Well, so when we talk about this word temperature, this is the degree or intensity of heat present in a substance or object. Many times we had to define it as the degree of hotness and coldness of a body. But well, what we can define the temperature to be, temperature is actually the measure of average kinetic energy of the particles. More is the average kinetic energy, more would be the temperature, or rather I should say, more is the temperature, more would be the average kinetic energy of the particles. Is this clear? So that is what we have as the average kinetic energy. Now, when we talk about the temperature scale which we had, remember there are certain fixed points or the zeros. Has anybody ever thought why the freezing point of water is 0 degrees Celsius? Have you ever thought of it? Have you ever thought that why the boiling point of water is 100 degrees Celsius? Why the freezing point and boiling point of water in Fahrenheit have a difference of 180? Yes, the freezing point of water and the boiling point of water on Fahrenheit scale have a difference of 180 degree Fahrenheit. But please remember, the freezing point of water on Fahrenheit scale is not 0 degree Fahrenheit. In fact, it is 32 degrees Fahrenheit. Do you know that? Any confusions with that? Let's understand that. Now, the problem is that water has a 0 degree Celsius as the freezing point because the freezing point of water was considered 0 degree Celsius. In the same manner, the boiling point of water was considered 100 degrees Celsius, and the gap between 0 and 100 was divided into 100 equal divisions so as to give the values. So that is what we have as the values. Is it clear? So that's what we had, the reason of Celsius scale. While Mr. Fahrenheit, he actually took a mixture of ice and salt as the zero. It is even lower than actual 0 degree Celsius, and the freezing point of water on that particular scale turned out to be 32 degree Fahrenheit. He added 180 to it, and the boiling point of water in Fahrenheit scale is actually 212 degree Fahrenheit. Do you know that? So, what's the boiling point of water in degree Fahrenheit? Anyone heard of it, what I said? What is the boiling point of water in degree Fahrenheit? Ananya Sarkar, it is a general trend in my class. The students are generally less. If I have a lot many students, that will be an exceptional behavior. Low number of students is not exceptional in my class. Most often the students, I don't know, maybe they are not ready to understand so much information, such a deep information. Well, their wish. Okay. Ananya, you need to give me a reason, if I teach so good, why there are no students. Perhaps there is some mistake. Okay. Fine. So, in degree Fahrenheit, it is actually 212 degree Fahrenheit. We can convert the degree Celsius into Fahrenheit, and we can have interconversions. Temperature is the degree of hotness or coldness of a body. It is the measure of average kinetic energy of the particles of a substance. If the two bodies have the same temperature, they have the same average kinetic energy per constituent particle. Please understand, it is the average kinetic energy per constituent particle. If we increase the size of the constituent particle, the average kinetic energy would remain the same, so the velocity actually decreases. Fine. We have the units of temperature, degree Celsius, Fahrenheit and Kelvin, and we can convert one particular unit into the other unit. We have degree Celsius is equal to degree Fahrenheit minus 32, and whole thing is to be multiplied by 5/9. In the same manner, degree Fahrenheit is equal to degree Celsius multiplied by 9/5 plus 32. So that is the conversion factor. This is a very common question you would have done in 9th class. Which temperature the Fahrenheit and degree Celsius scale would have the same magnitude? That is, there is a temperature which is T degree Celsius, that will be equal to T degree Fahrenheit. This value would remain the same. Could you give me the value of T? At this moment, school, it's 4:30 in the evening. What are you going to do in the school at this moment? Okay. 273.15. No, it is not 273.15. You need to calculate this particular question. What you need to do is, we have the degree Celsius is equal to degree Fahrenheit minus 32. So here what you can do is, you can write it as degree Celsius, yani ki T degree Celsius is equal to T degree Celsius minus 32 into 5/9. Now you can find out the value of this T. So T is equal to 5/9 T minus 32 into 5 by 9. Clear? So it would turn out to be, could you calculate it out? Jaldi se calculate kar do. Andana Sakar, I said that what would be the temperature when the value in the degree Celsius and Fahrenheit would be the same? Could you quickly solve it? So here, when we solve it, we can have it as 9T is equal to 5T minus 32 into 5. So just subtract it, it actually turns out to be 4T is equal to minus 160 and T is equal to minus 40. So minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. So this is the particular temperature at which the Fahrenheit and degree Celsius scale would show the same magnitude of temperature. Is this clear? So here we can talk about the magnitude of temperature. Now let's talk about the pressure. Pressure is, I believe everybody is aware of what pressure is. Pressure is able to do lot many things, but the outcome comes only with pressure, whatever be the outcome. So we get for the outcome we need to have some amount of pressure, otherwise nobody is able to do the work. So when we talk about the pressure, it's the force exerted per unit area. So the units could always be the unit of force upon unit of area. So it actually turns out to be Newton meter square, and this unit 1 Newton per meter square has been termed as Pascal. So Pascal is the SI unit of pressure. Everybody clear with that? So Pascal is the SI unit of pressure. Once we have talked about the SI unit of pressure as Pascal, now let's get along with further units of pressure. We have lot many units of pressure. We have unit as 1 atm. We have the unit as 1 bar. We have the unit as mm, Hg. We can even have centimeter of mercury. Now, what exactly is the meaning of 1 mm of mercury? What is the meaning of 1 centimeter of mercury? The meaning is simple, that we have a glass tube filled with mercury. So here 1 centimeter of mercury would mean that it is the pressure exerted by a column of mercury 1 centimeter in height. So that is what we mean as 1 centimeter of mercury or 1 millimeter of mercury. And then we could have even torr, or we could even have this torr. So these are the pressure units. If we have CGS unit, then it turns out to be dynes per centimeter square, but we are not going to go into those details. Now these are the interconversions of the pressure units. Most of the time students make a mistake in the units of pressure because most often they are not able to convert them. Remember, this is what we have as 1 atm. Now 1 atm is equal to 1.01325 bar. Most often it is written as 1.01 bar. But please try to get it as near as possible to this particular value. Okay. Now this is going to be 76 centimeter of mercury or 760 mm of mercury. Now this was the value which was measured, and it so happened that it's quite near to 1 atmosphere or 1 bar. So mercury, this is 760 torr, or it is 101.325 Pascal. So if you can see, the largest unit here turns out to be atmosphere and the smallest unit turns out to be Pascal. 1 bar is 10 raised to power 5 Pascal. There you need to understand 1 bar is the standard unit. 1 bar is the standard unit. Whenever we talk about the standard temperature and pressure, the pressure is 1 bar. It's not 1 atmosphere, it is actually 1 bar. So, bar is the standard unit. But here you need to understand that bar is not an SI unit. It is a standard unit but not the SI unit. Is this clear? Whereas 1 Pascal is the SI unit. Clear? So just be very clear about it. So that's what we have as the conversion factors. And now we are going to talk about uncertainty in measurement. Whenever you make a measurement, you would be finding that whatever unit you use, like let's say you go to the market and you ask for a kilogram of rice. Now, is it true that you are going to get exact value whereas the mass is concerned? Whenever you are going to get the rice, the person who is weighing it, it's always going to give a few grams extra. Whenever you buy the vegetables, is it exact weight? You always get a few grams or maybe 10-20 grams extra. So the person is not exactly bothered about exactness. So there is an error in the measurement. Most often, even if the person tries to give you exact quantity, still there would always be an error, and that error could be as much as the least count of the measuring instrument. Now there is a word called the least count which I have just used. The least count is the minimum value that can be measured using that particular measuring instrument, or it's the magnitude of the smallest division on the measuring instrument. So that is what we term as the word called the least count. Is that clear? So here, as you can very well see, if I talk about this gap, this particular cylinder has the least count as 1 milliliter. So this is the gap. Now here the value is in between the two divisions. So how do I know? So here I'll have to consider it either near to the upper line or the lower line, and I find it is more near to the lower line. So I would be considering it as 21, 22. So I would be considering it as 22 milliliter. This can't be measured because my cylinder does not have a division in between the milliliter scale. So this is going to be the error. Ananya Sarkar, beta, most of the cases the word itself needs to be defined. Is it clear? Now, so that's what we have as the error in the measurement. As we have already seen in this particular example, the volume is not precisely measured. Many times in the study of chemistry, one has to deal with experimental errors. As well as the theoretical calculation, there are meaningful ways to handle the numbers conveniently and present the data realistically with certainty to the extent possible. As chemistry is the study of atoms and molecules which have extremely low masses and are present in extremely large numbers, a chemist has to deal with numbers as large as, wow, what is it? 6.022 into 10 raised to power 23 particles, the Avogadro's number. So we might have to deal with Avogadro's number or extremely small numbers as 1.66 into 10 raised to power minus gram or kilogram, gram, 24 gram. This is the mass of one hydrogen atom in grams. Or the Planck's constant, 6.626 into 10 raised to power minus 34 joule second. I make a mistake. Many a times I have made the mistake. Maybe you have also made the mistake. It is not joules per second. It is actually joule second. Is this clear? So now we are going to talk about something called the significant digits. I hope you have heard of something called the significant digits. What are the significant digits? Have you ever heard somebody saying, my age is 5.000 years? Significant digits. Okay, I'll ask you a question. The number of significant digits in a measurement depend on, first one, A. Let's say A. The person making the measurement the least count of instrument, C. Both D. So what exactly would be the number of significant digits depend on? Whether I make the measurement or you make the measurement, will it make a difference in the number of significant digits using the same instrument? Or the instrument that we use is going to make a difference in the number of significant digits? Give me the answer. So, what would be the factor which affects the number of significant digits in the measurement? A, B, C or D? The answer is quite simple. It is the least count of the measuring instrument. Smaller is the least count of the measuring instrument, more would be the number of significant digits, because more near to the exact value would be the measurement. Now let us say we have been given a particular number and we are asked how many significant digits are there in that particular number. So, let us say the number is 0. Black is okay. No, I think I should be using white or yellow. The better symbol would be yellow. So, let us say the number is 0.0056003800. Okay. I have arbitrarily taken a very arbitrary number. So that's the number. What are the rules to determine the significant digits in a particular number? Now the first rule is all non-zero digits are significant. All non-zero digits are significant. So that's one thing. So here, the 5, 6, 3, 8, these are all significant digits. But when we talk about zeros, there are three kinds of zeros. Talking about the three kinds of zeros, the first kind of zeros are what we call as leading zeros. The leading zeros. Then we have the lagging zeros. And then we have in between. The leading zeros, the lagging zeros, and the zeros in between. The very first thing, leading zeros are never significant. Leading zeros are never significant. Can you understand that? All the students who have attended the class, have they marked it? Have they liked the class? The leading zeros are never significant. That's what we need to understand. So this is not significant. Clear? In between zeros are always significant. Hello Arnav. So you are able to understand everything that I am teaching. Have you liked the session? That is a must, that you need to like the session. So here we have the in between zeros are always significant. So that is what we are going to have significant. Okay. Now then we have the lagging zeros. So here we have 2 points. In a number with decimal. In a number with decimal, lagging zeros are significant. In a number with decimal, lagging zeros are significant. Fine. And then, no, I should not be doing this one. While in the number without the decimal, the lagging zeros are not significant. Okay? In a number without decimal, lagging zeros are not significant. So that's what we have as leading, lagging, and in between zeros, and that's what the NCERT says. Clear? So every experimental measurement has some amount of uncertainty associated with it because of the limitation of measuring instrument and the skill of the person making the measuring. So depending on which measuring instrument is being used, the number of significant digits is going to change. Clear? So what do we need? All non-zero digits are significant. For example, in 285 centimeter, there are 3 significant digits, and 0.25 milliliter, there are 2 significant figures. Zeros preceding to the first non-zero digit, yani ki leading zeros, are not significant. Whatever be the case, they are not significant. Such zeros indicate the position of the decimal point. The 0.03 has 1 significant figures and 0.0052 has 2 significant figures. Because these are leading zeros are never significant, whatever be the case. The zeros between the two non-zero digits are always significant. The in-between zeros are significant. Thus 2.005 has 4 significant figures. That's what we have already discussed. Zeros at the end or right of a number are significant provided they are on the right side of the decimal point. I would not say this way. I would simply say that if the number has a decimal point, then in that case the lagging zeros, that is the zeros which do not have any non-zero number to the right hand side, are significant. Is this clear? What is the meaning of lagging zeros? Lagging zeros are the ones which do not have any non-zero number to the right side. Leading zeros are the ones which do not have any non-zero number to the left side. Is this clear? Of course, Ananya, we are going to read the NCERT as well. Clear? Zeros at the end or the right side, okay? For example, 0.200 gram has 3 significant digits. But if otherwise, the terminal zeros are not significant if there is no decimal point. So, lagging zeros are not significant if the number does not have a decimal point in it. Clear? Now, there are numbers, counting the numbers of object, like there are how many students in a class, like how many pencils are there in a box, how many eggs are there in a basket. If you are not simply weighing them or putting an approximation, then in that case, that particular value has infinite significant digits, because these are the exact numbers. These numbers don't have any error. So, that is what we have as exact numbers. Clear? So, these are having infinite numbers of zeros and they have infinite number of significant digits. And here comes the precise or accurate. Have you heard of this precision and accuracy? Thank you, Ananya. You like this particular class. Now, here what we say, when we talk about accurate and precise, accuracy and precision are two things. When we talk about accuracy, accuracy is of the instrument. When we talk about the precision, precision is of the person. But obviously they work together. If we are hitting the bullseye, that is, we are hitting the particular point that we want to hit, and all the hits are absolutely at that same point, it becomes precise as well as accurate. If the points are very near to each other, but maybe not near to the actual point that we have, it might be the error of the instrument, not of the person. So, here it is precise but not accurate. If the points are not near to the actual value and they are far apart from each other, that means the person as well as the instrument both are full of errors, and that is why the measurement is not exact, not accurate, nor it is precise. The precision is about the various measurements being close to each other. Accurate is about the various measurements being close to the actual value. Is that clear? So, this one turns out to be not accurate, not precise. This is precise but not accurate. This is accurate as well as precise. So that is what we have as the various measurement, the various answers. Anything you would like to ask here? Now we might have the conversion from one system to the other, and we would use the conversion factor. Now just remember, the conversion factor is not a dimensionless quantity. Now let us say one very simple thing. We have 1 meter is equal to 10 raised to power 3 millimeter. 1 meter is equal to 10 raised to power 3 millimeter. Now, what I understand is 1 millimeter now to have the conversion factor. I would get 1 meter by 10 raised to power 3 millimeter is equal to 1, or I can get 10 raised to power 3 millimeter by 1 meter is equal to 1. Okay. If I want to convert the meter into millimeter, this is the conversion factor I need. Millimeter, no, it is meter to millimeter. Whichever quantity I need, that must be in the numerator. Okay, the quantity being converted must be in the denominator. So to convert meter to millimeter, I need to multiply it by 10 to the power 3 millimeter by 1 meter. On the other hand, millimeter to meter, meter is to be in the numerator, while millimeter is in denominator. The quantity that I need should be as the numerator, and the quantity which needs to be converted must be in the denominator. Is that very clear? So that is what we have as a simple thing called the conversion factor. So Iconic Mega Sale Week is there. Prepare today, prosper tomorrow. Today you are going to get a 35% discount, 15 plus 20%. It's actually not 35%, it's 15% first and 20% later. It will turn out to be 33% or something like that. So this is what you are going to get, 15% and 20% discount. So use the code AVLIVE for the purchase on the Iconic or the Target NEET UG or whatever things you want to buy. Just go ahead and buy it using the code AVLIVE. That's going to give you a 33% discount. Clear? And with that you will be able to join the plus courses. So many plus courses are at this moment going on. We are also going to launch a plus course very soon. So you can go ahead and take the subscription. 3 p.m. every day it is Dr. Sachin Kapur with biology. 4 p.m. every day it is me, Anoop Vashishtha, with chemistry. So just mark it in your calendars that 3 o'clock and 4 o'clock you always are going to have some or the other sessions. So this is how you can join with the Unacademy app. Very soon we are starting with the special classes. These are free classes, and for that also you need the Unacademy app. So quickly go ahead and download the Unacademy app. Unacademy Learn app, you can just get it from the iStore or you can get it from the Play Store. Just install it, select your goal. You can get lot many goals. Whatever is your goal, go ahead and select it. You can actually select more than one goal as well. So you are going to go ahead, use subscription plans, use the code, join with the subscription, or simply use the code to get along in the app. So here we have Iconic Plus and the centers. You can get the subscription At this moment, you can save up to 35% on all subscription, which is valid only till July 15th. And today is July 13th. So we have very few days left. If you wish to join any of the Plus courses, go ahead and join using this code. So subscribe to Unacademy NEET Elixir. That is our channel for the best live classes. Like, share, subscribe and comment how did you like this session. Thank you. We are going to meet you in the next class, that is going to be tomorrow, chemistry class at 4 p.m. So till then, bye-bye, take care, good night.